Going on, guys. So we have this question right here. It's asking, show that the equation x7 plus 4x5 plus 3x plus 12 equal to 6x has at least one real root. So since we have this kind of question, the first thing I would like to do is I would bring everything into one side. Let's do that. So it's going to be x7 plus 4x5 plus it's going to be minus, right? So this is going to be minus 6x square plus 3x plus 12 is equal to 0. So I have brought everything to one side. Then what I have to do is, since they ask for real root, so we know the root exists when x is equal to 0. So we had to find whether the function is continuous or not to say whether it has root. So let's see I take the value f of 0 and check with this one. So if I apply 0 for this equation, first of all I write this equation as f of x is equal to x7 plus 4x5 minus 6x squared plus 3x plus 12. So now if I plug 0 for this one, it will become 0 0 minus 0 plus 0 plus 12. So the final answer is 12, right? Everything is 0, so for 12, and we know it's greater than 0. So let's take another value. I take a negative value, negative 1, let's say. So if I plug negative 1 for this one, it's going to be negative 1, or it's odd number, so it's going to be negative 1 minus odd number multiplied, so it's going to be 4, and this is going to be minus 6, and the next one is minus 3 plus 12, right? So if I add all of them together, I will end up getting negative 2, and we know this is less than 0. So since we have this value, we know that this function is continuous because we have a value that's greater than 0 and less than 0. Therefore we can say we have the interval negative 1 0, and in the negative 1, when I take negative 1, this is less than 0, and when I take f of 0, it's greater than 0. Therefore this is continuous, right? Continuous. And what we can say from this is, by the intermediate theorem, intermediate value theorem, there's a C exists in this case. So C means the connecting thing to this thing, so it's going to be f of c is equal to 0. So therefore this equation has at least one real root. So we can say therefore this equation has at least one real root. That's the final statement you have to write. So I hope you guys like this video. See you next time.